Broadcasting from Boston, Massachusetts, the ARC Digital Transformation Viewpoints podcast is the only podcast dedicated to all things related to digital transformation in energy, industrial, and critical infrastructure applications. The podcast is the creation of the ARC Advisory Group Digital Transformation Practice. ARC advises leading companies on technology trends and market dynamics that affect their business. To engage further, please like and share our podcasts or reach out directly on Twitter at ARC_advisory, or please go to the website at www.arcweb.com.
Welcome to another in our digital transformation podcast series. I'm doing a series now with a good friend, longtime colleague, and one of the guys that I trust whenever I'm looking at the future of technology, Rick Bullotta. We're going to talk over the next few episodes about really industrial systems engineering in the new era of AI. But in this first episode, we're really going to talk more about what Rick has learned over a few decades. And Rick is, for those that don't know Rick or haven't crossed paths with him, he's a seasoned innovator and thought leader in industrial technology. He was co-founder of Lighthammer and ThingWorx. And if you don't know those names, well, Lighthammer became SAP Manufacturing Integration and Intelligence, and ThingWorx was acquired by PTC. He's played a pivotal role in shaping the future of connected systems, digital transformation, and intelligent automation. I think of you, Rick, as a serial entrepreneur. I know you advise a lot of startups and investors, and I do view you as one of the experts in industrial AI specifically, advanced manufacturing, including, I know you're really digging into robotics nowadays, and the intersection of data-driven insights with industrial operations. You've helped drive efficiency, intelligence, and scalability in some of the world's most complex industries. So welcome to this series of conversations, Rick.
Great to be here.
So why don't we dig in and kind of lay the data foundations before we get to kind of the new era of AI, because we've got a mixed audience. You know, we've kind of got IT, OT, and nowadays, of course, data scientists all, I hate to use the word convergence, right? Because it's not necessarily about they all have to be fully aligned, but they need to collaborate on kind of the data problem. So I think it's worth spending this first episode, right, talking through what you learned. And let's start with the Lighthammer days. What was the single biggest data challenge you were tackling on the factory floor back then?
Yeah, I would actually go one prior to that.
Okay.
Okay, if you think about what Wonderware did, it solved, and companies like Wonderware, Evolution, and so on at the time, we had a disparate set of physical devices, right? We needed that last foot of connectivity, zillion different weird protocols, and we needed to kind of connect all those together. So that was kind of the first epiphany that there's an interesting opportunity to just connect disparate systems. So I spent a couple of years at Wonderware, and then the next thing you notice is when you start working with enough large customers, particularly the larger ones, they didn't just have Wonderware. They had other SCADA systems. They had historians, MES systems, homegrown systems, quality, all this mishmash of stuff. I remember talking to one of our customers, Lighthammer had like 400 different systems, not 400 instances, but 400 different plant systems. So I kind of said, all right, well, what's the logical next step? What's the way we can kind of give a unified view? And that was the original focus, was a unified view of all those systems. I think you were involved, and you kind of remember when we were in the AMR days, we're trying to grab a name for that, right? And I guess we called it you coined the term enterprise manufacturing.
Yeah, I coined the term with some help. We obviously had a good team back then, enterprise manufacturing intelligence. And I think that was really enterprise because we wanted to convey, to your point, that there were in some cases hundreds of factories and they needed a view across those factories. Manufacturing, right? Clearly because we wanted to differentiate it from what was the in vogue business intelligence term of the day, which didn't include typically the factories. So yes, that was the term I think it's still floating around. I still see it in marketing materials. But yes, and hadn't forgotten the Wonderware days, but I thought, but it's a great place to start. I agree. Yeah.
Yeah, and so then the Lighthammer stuff obviously was the next level up. The inputs now are the systems, not the devices per se. We kind of felt like that had been solved. They're more often than not, they're bringing that device data into something. So even then, it was still a bunch of goofy APIs. Even if they had APIs, we had to reverse engineer a ton of systems to find our way in. But and even the conventional things like SQL databases, just there was data everywhere, inconsistent formats, and the fact that we focused initially on visibility was sort of an obvious value multiplier when people could see, in one pane of glass, data from you're trying to solve a quality problem, right? It's going to require data from a bunch of different streams, even if initially the human had to be the one that bridge inferred the context. So the quote unquote plan information portal was the first play there. And that was all about unified visibility. It's kind of early web. So it was, there weren't a lot of solutions at that point that you could deploy in a browser. So that to the enterprise part, that remote access to stuff, right? It really wasn't a cloud then. It was typically, right? But now you could have quote unquote remote smart people, whether it's an outside vendor helping you solve a machine problem or the expert in a process helping you diagnose, something in your Puerto Rico plant or whatever. It was, it gave you the ability to work remotely. Second thing we realized, and this kind of grew out of what some of our customers were doing and the SAP influence, was that if you can expose all this information to people in a unified way, you can expose it to machines and systems in a unified way. That's where the integration part of it came in. Now, other systems could grab data, be triggered by events from the factory floor to kind of move business processes along. But still it was a mess, right? It was the, scale.
No pun intended, right? Yeah.
Yeah, right. But the usual stuff, right? And I think the other side effect was we see a lot of discussion now about standards and how we represent data, metadata, all that stuff. I'm not saying it was right, wrong, or the best, but at least you had a unified way to browse the data that was available and a unified way and a consistent data format when you asked for it. And that, I think, was a real powerful enabler.
So when you created solutions for what then became SAP's manufacturing integration and intelligence, what were the immediate wins and what data problems did you find were not so easy to solve? You've kind of laid out what at the time was obviously a very compelling vision, and SAP acquired Lighthammer to kind of fast track that. But I'm sure you ran into a number of barriers and limitations of the approach. So maybe talk through some of those early learnings.
Yeah, I mean, the most obvious ones that we and our customers would encounter were just fundamentally closed systems. At that time, there were systems that still lacked an API. You might have to go directly to their data store and reverse engineer that. That was probably the biggest obstacle. Is can you actually get at the data? I think today, sure, we definitely still see that in a lot of vendor systems, OEM machines that lock it down tight, but it's much less of a problem than it's done. The big wins tended to be, just like I said, the human collaboration on like a quality problem is a great example, right? Because, and actually even just visibility to what was actually going on. You'd be amazed how many like plant managers and supervisors had this perception of what was going on the plant floor. And Russ used to tell this story about we're demoing against some live data. It shows a couple of machines haven't started and it's like 30 minutes into the shift. It's like, no, it must not be working. You're not getting the data. I'm like, no, we don't think so. Sure enough, go outside. Things aren't up. The line's not up yet. So it was that kind of aha moment for a lot of people that real-time visibility can help change. But
right.
Obviously you can act upon it. Second thing, you can bring a bunch of experts together, or just people together, to solve problems.
Yeah, and I think when we coined the term back then, it was also because the particular analyst firm I was with at the time was known for supply chain as well, right? And so it was an attempt to kind of bridge that gap where a lot of supply chain decisions and supply chain visibility was a big thing as well, right? And so this was our counter or complement to supply chain visibility. And I kind of almost see that repeating itself now as I see people talk about reconfiguring supply chains. And it's like, yeah, but you're not including factory in that risk analysis and modeling. How are you really going to do that? There's more constraints than right? In the factory.
That's probably changed a little bit, and I guess for the better. Like, I thought this was going to happen faster than it did, but at the time, so many companies had highly integrated supply chains. They were all, we didn't see a lot of contract manufacturing back then. They were just now, supply chains are so dynamic, distributed, and so on, that it sort of shifts. That's kind of where, cloud kind of stuff has some value. Right now, it's those APIs, that data is exposed to the whole value chain in a common way. We didn't really have that need at that time so much, though some customers did use it to expose, quality data up and downstream, status data, things like that.
So you kind of highlighted I guess the main problem that you experienced in the MII days was really still proprietary systems, or no easy way to get at the data in some of those systems, right?
And no natural context. It was like it's
right.
No different than a master data management problem, when you're bridging an ERP and a separate schedule, whatever. But then you see some patterns that jumped out, right? In industrial data, we used to call it time fencing, right? So a lot of the data that you're looking at, this batch ran on this machine from 1:15 to 2:07. So that's context. That says, here's the time window. The machine tells you, here's the tags that are the data points that might be of interest. So knowing that kind of when you can infer that kind of context, we could present the data to the user without them having to, figure all that out to do this.
Right.
The other epiphany, I think, at the time, and I'm not sure this is, again, right, wrong, or other, was that there's so much data in these systems, and storage was not free then. So the idea that you would duplicate data made no sense. The idea was to leave it in the source system, or sometimes mirror it, but leave it in the system of record, and then do that correlation at the next level up. Do that kind of contextualization, aggregation. That turned out to be really important, because you're not going to replicate your entire Pi server data, in a SQL database. You'd spend infinite amount of time and money, doing that. Today, that's kind of less of an issue. People lift and shift all their data to the cloud. The other thing that we saw is that people are using this for near real-time decision support. So just the latency of moving it would be always guaranteed to be late, right? If you had to ETL it. So going to the source system where possible, and then the recognition that you had a couple other thoughts that we had were you have current data, which is extremely interesting, right? Okay, what's the state of the business? We call that a UNS today, right? It's the buzzword. Right. The historical exhaust of just the normal censored time series stuff. But I think a lot of people got focused on the assets and machines, the historical exhaust from the processes. That was the MES stuff. That was the stuff in the SQL database. Merging all that together, that's when a lot of the real insights came.
Right, and I think, if I remember right, the model that we kind of proposed at the time was kind of integrate, aggregate, contextualize, that magic word, right, and then visualize, And then we had this idea of propagation, but it was kind of like optional. It was like, hey, I need to take something inferred from that data, maybe a transaction or an event that I've synthesized from the lower levels of that into something that does belong in an ERP system or an asset management system, triggers a work order or an adjustment to a schedule or something. So yeah, it was a good reminder. I'd forgotten everything was on the cloud, and yes, we tend to fast forward to storage is cheap, and you don't really think about that as a significant cost anymore, right? But
well, when you had to, I think also, their IT was more heavily involved. A lot of these systems instead of sometimes they were hosted on the plant floor. As we got into our larger customer deployments, IT took ownership of it. It was a critical part of what they did. The other thing that evolved, so it started out at kind of basic data access and visibility. Then you realize you need data transformation. So how do we make that easy? How do we make it so you don't have to write goofy, requests from your external system? So we added this tool, became a pretty integral part of the product for both. It really was industrial data ops at the time. So you could draw, it's called Execute. And you would draw these, drag and drop these blocks into different kinds of transformations, aggregates, SQL-like things, merging data. In essence, it was sort of allowed you to do SQL-like things on any kind of industrial data, wherever it came from. And then you could transform it. Maybe that was just to visualize it. Maybe that was to aggregate it and store it away. Well, that kind of flow chart thing then became the foundation for the actionability side, right? Oh, when this happens, do this, transform this, update your ERP system, send a message. We see that. Everybody does that.
Yeah, we'll revisit that, I think, later in our discussions, because that, to your point, has become kind of a industrial data ops is probably the common term being used for it right now. But let's maybe move forward to the ThingWorx era, right? Or really the rise of industrial IoT and how that changed the nature of industrial data. Not entirely, but it did add some new dimensions to it. So what was it just more data? Was it different data? Was it fundamentally different?
I think we started leaving the plant, which was a big change, right? So now you're getting data about the product as well, potentially, right? The product or the machine goes out into the field. You need to, the life cycle of the product continues long beyond after it leaves. So that was kind of the IoT side of it. But the synthesis of how it performs and behaves out in the field, how it's serviced, is really powerful feedback into the how you make it, how you design it. Mm-hmm. Jim Heppelman at PTC, when he acquired ThingWorx, he had a very, very good vision for kind of how all that stuff fit together and the virtuous loops that could create. We didn't realize that at the time. We kind of were just going after two hot the known market. In many ways, ThingWorx was an evolution, newer technologies, more distributed architecture. For the IoT side, it was sort of fundamentally new the way we did that. We realized IoT was more than just data, so we had to do all the boring stuff like device management and firmware and software updates. But the data from those things was still what drove the value for the most part.
Yeah, and as you mentioned, all right, factories are distributed, but very often you were solving one factory problem and giving them visibility. But as we entered IoT, it was you had the product in the field, and you were trying to collect data from it to create that virtuous feedback loop, right, on how the product was actually being used or how it was performing, right?
The other thing that I think changed for us, and this is definitely a data element, is we started to realize the value of unstructured data. Mm-hmm. So unstructured data could be everything from an SOP or it could be shift notes, it could be the discussion between people to solve a problem. That is really useful knowledge. So, and it never got fully leveraged inside ThingWorx, but we baked in chat, discussions, document importation. That was kind of a core piece, and there was a search engine called Squeal on top of that. In many ways, it was kind of like a precursor to what some folks are doing with LLMs and RAG and MCP. The idea was, I'm dealing with a situation. Give me all the available data or assets, I should say, that can help me. Documents, data, even visualizations. So a big change from Lighthammer to ThingWorx was we now had a first-class tool to let you do low-code UX development. So building those, and it was more than just dashboards. They were, VB-like applications. So it was our bringing the low-code element to that. And then the what we called Squeal was an attempt to bring that kind of total ad hoc. So it would, similar to the context example I gave you for Lighthammer, imagine I'm troubleshooting something. Why can't it just automatically generate me what's been going on, a chart for what's been going on for the last hour? Because that's a valuable tool to help me, deal with that. So in a way, you could call that generative content development. There was a lot of things that share some similarities with what we're seeing today, but we just didn't have the advanced technologies would have made that so much easier.
Right. Okay, so maybe let's, right. So you've got lots of experience, not just with Wonderware, Lighthammer, ThingWorx, but before we kind of get into our next few episodes, I really want to make sure we kind of round out, based on all of your experience, connecting countless devices and systems, everything from factory to field service, right? What are the persistent hurdles in getting reliable, contextually rich data out of those industrial operations, whether it's in the factory again, or it could be an asset management or service type use case, right? So I don't want it to be just about the factory making the product. Very often it's the after sales service or maintenance of the actual production assets and equipment itself, right?
A lot of the obstacles were the boring technical ones we discussed, which were, can you even get at it? Second is that bastard, it's got this, the asset has this ID in one system, this ID in another, this ID in a third, the MDM kind of problem. Bad data. Timestamps are notoriously, difficult to normalize. Developers would love if the world was all on UTC and we all spoke English and so on, but that's not the world we live in. And here, this is, I think, another big takeaway. It's not just about normalizing that data; it's normalizing the metadata as well, right? So, in a perfect world, you don't need to know what that system has. You can interrogate, you can learn what it has, and then build applications. The tooling can learn that and help you build apps. It's just like browsing a list of tags in a PLC and a SCADA system. It's kind of the next level up of that. So building that metadata infrastructure, we thought was also important. Repeatability to deploy, like everything works great in a demo and a small. To do it at scale is a completely different thing. And we learned a lot from some of our larger customers at Lighthammer about things like reusability, governance, access controls, all that kind of stuff. So here we're talking about, when I think of data too, it's the data that comes out. It's also, you have the ability to, write to these systems too. Things can blow up, right? People can get hurt if we do the wrong thing there. So thinking about those kinds of aspects. But yeah, it was just, the kind of the hard information problems we get in the IT world, just compound them by 10, right?
Yeah, I think what hasn't necessarily changed is the fact that there isn't really a SAP of the factory, right? Yes, we have big industrial automation companies, but I haven't been to many factories where, it's just a Siemens factory, right? Or a Rockwell, pick your player. It's usually hundreds of different types of PLC or industrial equipment or the sensors and weighing scales and whatever they have, right? They come from.
Well, as you know, I was a systems integrator. I made a lot of money, solving that problem the old-fashioned way with, a team of us working, writing custom solutions. So that problem's not going away, right? We're not going to, even in greenfield sites, there's still these challenges.
Right. So we still have that heterogeneity. We still have a lot of, we haven't really dimensioned, I guess, the amount of data, right? Which again, I think is something that maybe some of our IT and data scientists don't realize, but that's why everyone wants to tap into it, because we have so much data that could be mined for useful insights or used to do more intelligent processes and automation. And you kind of hinted at a little bit that with your larger customers, you kind of started realizing the scale. But do you want to talk a little bit about?
Yeah, sure. That was like, I used to have a slide in my presentations about how have you ever visited the BASF facility in Ludwigshafen? It's enormous.
Yeah, no, I've watched videos of it. That is one I haven't been to yet. Yeah.
But the amount of data that was generated, this is, back in the day, from that facility exceeded the amount of raw data from all of the U.S. stock exchanges combined on a daily basis. And that was like a light bulb moment for a lot of people. You also realize that data generally has a short half-life, right? It's interesting for a time. And that was true then. I'm starting to think now that that's changing a bit as we need more and more data to train, AI and machine learning models. That retaining data with context, right? To train stuff, you still need appropriate context. But maybe we're starting to find more value of that historical data. And at the time, I would make the case that the SAP of that, the closest, would probably be OSIsoft, right? The amount of Pi data out there in terms of, petabytes of industrial data, I would suspect they, from a vendor standpoint, had a lot of that. So, but in general, it was still super, super fragmented, but it was enormous. The latency, the data is changing at extremely fast intervals, right? So the volume of the data was very high. Right. Just a lot of different factors versus transactional data in an ERP or MES system.
Yeah, I mean, petabytes of data, a lot of it time series. To your point, I think historically, a lot of it, yes, was useful for control, real-time control, but maybe we kind of assumed it had little value after that. And to your point, I now see discussions of industrial foundational models, right? Where they're going to need massive amounts of data, but they also need somebody to share it, right? Because no one owns all the data that would be needed to create that foundation model that really understood some of the data types and equipment models and all the different things that we have. So I still think there's going to be a lot of discussion about how much of that data do I really need to keep and use for training, and also whether it needs to be provided in real time, because a lot of that training could be done, future date, as long as it's before the plant has changed too much, right?
That's the thing. That's important context is too. I learned when we did we had a pretty good quality module, which was would do SPC, SQC, all that kind of stuff. And folks, it's not SPC and SQC is not just a chart. The limits on those are supposed to be set and calculated for specific, effectivity dates. When you make a change to a process or a change to a piece of equipment, the process capabilities are going to change, right? It's not just a chart you run. So that's true of if we're going to try and use this data for advanced whatever, you need to understand that element of context as well.
We're back to the time boxing or yeah.
Yeah, and it was, it's basically a different factory after that point because we changed. I think the other thing doesn't get enough attention is really thinking about the intersection between asset data and process data. Right. Like there's people that are really, really good. You'll see foundation models for a pump or this or whatever. Processes are so diverse that they're going to need to be generally learned kind of on a very unique, specific basis. But the intersection between those two is super important.
Right.
And I just don't see enough effort going into process data analytics in ours.
Yeah, and we've got multiple episodes where we can explore these things further. I don't want to jump too far ahead right now. Let's maybe pivot. We kind of started talking a little bit about data and how useful it may be for this new era of AI. So kind of getting ready for the next episode, maybe, right? Maybe just talk about what are the lessons that immediately spring to mind about, okay, we still have to do all these things that we had to do through kind of the MII era, if you like, where it was more about connecting devices that didn't necessarily have APIs, and certainly they don't all support OPC UA today either, right? But you had that, and then you kind of had the addition of the kind of IoT devices that kind of got us out of the factory, but also different distributed data types. So that was kind of another evolution. But now, as you start to think about, and I know you're building AI solutions and working with startups that are building AI solutions. So maybe kind of what are the things that you're now seeing surface that add to those challenges?
Great question. Increasingly, it's going to be the unstructured or semi-structured data, right? The human data, as we lose, we're all aware of the brain drain, the skills challenges, capturing that. Another one that's I'm doing some work in these areas is image and video data, where the data isn't our traditional kinds of things, but the amount you can learn. We're all familiar with vision inspection systems, but now the ability to use relatively low cost vision and edge analytics and so on to do cool stuff, that's super powerful. And now we're moving and shifting that into video. Like, okay, I can infer from the video that person is doing the task unsafely or incorrectly, or I can automate instead of them having to go over and type in how many parts they made. I can watch and do it for them. So really interesting kinds of I call that kind of meta sensing, right? You're taking some input, video, image, heat, and then you're turning it into something else, a product count, a state, something like that. So new forms of data, that's definitely kind of one of the areas. And then again, this unstructured human knowledge, we're just going to have to figure out a way to capture and share better. It's not a technology problem.
No, yeah, I would agree with you. It's not it's a technology opportunity, right? In the sense that we now have, you and I talk about this often. It's not necessarily new technology. It's just at a lower price point and easier to use, right? But we now have sensors or camera sensors. Sony is obviously one of the players in this space, but just the cost of those has come down to such an extent and fast enough that we can do things in the factory on the edge.
Yep.
I remember seeing Zeiss as well, right? Showcasing what they can do with some of these vision systems on the edge, and that's a couple of years ago. And computer vision has been even though it hasn't been the area really getting the investment, it's benefited, right, from driving down the costs and some of the mixed multimodal, right, work that's gone on, right,
beyond inspection, right?
Yeah.
What's funny though is almost every new macro trend with data or whatever, you can find something that paralleled that with different technologies 30 years ago. It just popped into my head, like 32 years ago or so, probably a little more than that. You could take an Excel spreadsheet and you could bring live data into it from PLCs. You could bring data in from historians, and you could do dashboards in a spreadsheet in live, right? And that data would update. So, we've had a lot of these capabilities. As to your point, they're becoming easier. They can connect to more things. We're democratizing the skill sets that are needed to kind of leverage it to a point. I still think you need knowledge of that's a reality. You do need some knowledge of the underlying systems you're tapping into. I'm not yet a believer in the just let AI and algorithms crawl it all and they'll figure out all the relationships. It can help, but it's not a there's no magic button there.
Right. Look, we're going to get into in our next episode. I think we'll really start to focus in more on what I've been calling industrial grade data fabric. Right, it's kind of addressing the data quality problem, the data ops and AI ops audiences. And as I've been doing a lot of that work, I find I'm revisiting, right, a lot of the history on, well, it's still about how do I, make sure I'm not feeding poorly calibrated instrument data, or an instrument is actually off, and yet I'm still picking up a faulty reading from it, and I'm feeding that into an AI system. So I'm still running across lots of confusion, and I always keep coming back to, well, it's about the data quality first, right? I think later on in the series we'll get more into, okay, let's assume you've addressed. And you don't have to address it all at once. I think that's the other thing I'm really concerned about, that people think they're just going to ingest all of the data into a lake house in the sky, and suddenly that will be there for everybody to go and build their AI solutions. And very few have the appetite or the budget, frankly, to even though we said it's relatively cheap data storage, when you talk about the amount of data that we have in factories, and then the fact that it has no context, if you just take that approach, right, then there's a lot of steps in between. So I think we'll get deeper into that. But maybe for this episode, some closing thoughts on what are the data challenges you've seen over the last, let's just say 20 years, right? Maybe 30, I'm not sure, that still manifest today in companies trying to adopt AI, and you're seeing them repeating the same mistakes or all over again.
Let's start with customers should not accept closed systems. Like, let's just make that a non-starter, right? If a vendor gives you a system that you don't get access to the data, I'm sure there's some exceptions, right? Some critical, but that should be a non-starter. Like, okay, I buy your system, I'm entitled, and if a vendor wants to charge something for that, that's a separate discussion. But you should be able to get at what is effectively your data about how your processes run on that equipment. So that's a foundational one. I think more companies should have internal kind of consistency, some best practices. Standards is a strong word on how they name things, how they scale things, how they, you can deal with the MDM, the master data management tiger after the fact, or you can deal with it, as part of how you build systems.
And I think we'll get on to talking about unified namespace, kind of more on the, let's say, on the OT side of the equation. And then I guess if I thought Databricks, I think the idea of a catalog has maybe taken over from master data management, but it's still fundamentally master data and meta management, right? Yeah.
Exactly. And, they are important. So when a system is open, it opens up its data and its metadata. That's, kind of a key foundation. But those are kind of if we can solve those, that will go a long way. And we need to be smart about giving access to, I've also seen security is not, we joked the other day that, the S in MCP is for security, right? That was one of the most brilliant blog titles ever. But similarly, our systems, right? They're sensitive data. You can infer from data in an MES system the secret formula for, products. There's just, you have to start thinking about those kind of more mundane infrastructural issues as well about data, how you want to share it, how you want to aggregate across sites. You've got data regulations to deal with, right? Where data can't leave certain geographies.
Right.
But it's just your own data. I think that's probably a different story. But nevertheless, these non-super fun, the non-fun stuff, right, is also needs to be considered. And that's where our partners in the OT side of the fence can help.
Right. In the IT side of the fence, I think you meant to say there, but
they're all the same.
Yeah, great. All right, let's call that one a wrap. I think we've got plenty to talk about in. I think in the next episode we'll really start getting into what you need to do to differently or additionally, shall we say, to kind of get ready for the use of all of this data for the new era of AI. And then I think we'll move on to the more fun stuff let's say we've cracked that problem, at least for some subset of that data, and we now want to build solutions on top of it. What does a modern
stack
solution really look like? Because there's a lot of, and we've touched on a few of them, there's MCP and there's Kafka and there's graph databases and vector databases. And anyway, do we need to talk about all the technologies? Maybe not, but there's a few key ones that I think are fundamentally driving the way we rethink. And we'll get into agents, I'm sure, as well, right, at some point in the conversation. But
my one mantra that we'll try and bring through all these episodes is you'd see me put it on LinkedIn all the time, and not or. These aren't binary decisions.
Right.
All problems, we're going to need, polyglot databases. We're going to need different, a lot of different tools, approaches,
right,
solutions, perspectives. And let's keep that, in the back of our mind as we do
right. ERP isn't going away. SQL databases aren't going away. Right. But we have lots of new unstructured data and way of adding context to that I think drives a lot of those newer approaches, but we'll dig deeper into that. But in the next one, we'll kind of stick to the data theme and talk more about what is that next level of data governance, security, management, industrial data ops, kind of meeting the enterprise and the data science audience will be the theme for our next podcast. So I look forward to that conversation with you, Rick.
Talk soon.